Good morning. Good morning, students. Okay. So that is structure of atom. Okay. So what we had discussed in the last class? Anyone? 1 minute. Okay. So what we had discussed? Any one of you can tell me what we have discussed in the last class? Okay, spin quantum number. Yes, Suchita. Yes, we have discussed about spin quantum number, and before that, even we have seen what will be the value of magnetic quantum number. Okay, so along with that, as we have told, we have discussed about spin quantum number, right? So that's what we have discussed in the last class. Then we had solved some of the one problem related to this, right? And I had given two problems to you, and before I was leaving, some of you were giving the answer, okay? And another thing, what we know here is, when it comes to total number of subshell, total number of subshell in a shell or energy level, in a shell or energy level, it will be equals to anyone, total number of subshells in a shell, in a given shell, in a given shell. How much it will be? Yes, Stephen. But for this one, total number of subshells, yes, it will be equals to n. That is the number of that shell itself. That is the number of that energy level itself. So principal quantum number. Okay. Now total number of orbitals. Total number of orbitals in a shell will be equals to total number of, yes, all of you are right. So in that case, total number of orbitals in a shell will be equals to, very good, it will be n square. It will be n square. So total number of electrons in a shell will be equals to, total number of electrons in a shell is equals to, yes, very good, it will be 2n square. That's where we have the important equations or relations. Okay, so this is with respect to a particular shell only. Okay, all of you are right. So that's where if I want to find out total number of subshells which will be available in a given shell will be n, and total number of orbitals in a given shell will be equals to n square, and total number of electrons in a given shell will be equals to 2n square. Okay, so that's what, based on this we can solve some of the questions very fast. But when it comes to board exam, we have to follow the steps, no doubt. We have to follow the steps. Okay, hagadre, what was the question? So that one was related to calculate the total number of orbitals and total number of electron when n is equal to, if I am remembering, it was 2, right? So when n is equal to 2, what will be the total number of electrons and total number of orbitals when n is equal to 2? Hogalwa. So that was the question, n is equal to 2. Now that means when they are telling n is equal to 2, that means they are talking about energy level 2. Okay, only one I will solve. If you have any doubts, let me know. So energy level will be 2. So that means total number of subshells, total number of subshells will be equal to 2, because we are dealing with energy level 2. So total number of subshells will be equals to 2. Once again. So which is that? That is nothing but S and P. Right? That is nothing but S and P. Those subshells will be S and P. Right? Now, all of us we know that when it comes to total number of orbitals, when it comes to total number of orbitals, it will be 2 square is equal to 4. That is because S is having 1 orbital, right? And P is having 2 orbitals. P is having 2 orbitals. So therefore, total 4 orbitals. So therefore, total 4 orbitals. Got my point? So next we have to calculate total number of electrons. So total number of electrons, it will be equal to 2n square, that is nothing but 2 into 2 square, that is nothing but 8. So that is nothing but 8. Okay. So total number of orbitals will be 4 and total number of electrons will be 8. Absolutely correct. So that is because S subshell, since it is having 1 orbital, maximum it can accommodate 2 electrons. P subshell, since it is having, okay, no, wait. So S is having 1 orbital, P is having 3 orbitals, sorry. So P is having 3 orbital, I have written it as 2. Okay, P subshell will be having, since 3 orbital, total electrons can be 6. So therefore 8 electrons. That will be the final answer. So there should be a correction. While writing I wrote it as 2 orbitals, but while giving the answer I told 4 orbitals. Okay, so that's where we have P is having 3 orbitals. Yes, absolutely correct. And due to that it can accommodate, each orbital can accommodate maximum 2 electrons. So therefore it will be 6 electrons with respect to P subshell. So 6 plus 2 is 8 electrons. Okay. So all of you have understood. So when n is equal to 1, total number of orbitals will be 1. Total number of electrons, it will be equals to 2. Very good, because only S subshell will be available when n is equal to 1. Okay. All of you have understood. So in that case, shall we move to the next one? Shall we move to the next one? Fine. So that is boundary surface diagrams. Okay. So that is boundary surface diagrams. Okay. We are going to discuss about this one. So I can tell this one as very important, because they will ask about to write the structure of subshell, shape of the subshell. Yes, Rohan. Okay. So that's where we have the boundary surface diagram, because in our board exam they will ask for 3 marks, 2 marks and all, they will ask to write the structure of P subshells, or to write the structure of 2S subshell, or to write the structure of D subshell. So for that there is nothing but boundary surface diagram only. Okay. Now I can tell that this is the boundary. Since there is a boundary, this is the boundary which is enclosing, boundary which is enclosing the regions, which is enclosing the regions where probability of finding the electron is high. Probability of finding the electron is high. So that's where we have the boundary surface diagram. So what do you mean by boundary? Each of our house, it is having a compound, that is a boundary. Our nation, it is having a boundary. Okay? So man-made, everything is man-made, no doubt. So now that's where boundary surface diagram is also our man-made only, imagination. Okay? So this is the boundary which is enclosing the regions where probability of finding the electrons will be high. All of you have understood? Now the question can be, draw the boundary surface diagram for 2s subshell. Draw the boundary surface diagram for 2s subshell, or it can be 3s subshell, whatever it might be. Now first and foremost thing, if the question is based on S subshell, if it is based on S subshell, first you should write here is S subshell will have, S subshells have spherical shape. It will be having spherical shape. That will be your first sentence. Okay? Now, if they ask about 1s, then you should show the nucleus, then you should show the line inside which we have to fill the dots. Okay, inside which we have to fill the dots. So this is where we have the boundary surface diagram for S subshell. Okay? All of you have understood? This is where we have the S subshell. Okay, I will come to that, Rohan. Okay? If they ask about 2s, if they ask about 2s, so you have to show nucleus, no doubt, we have to show nucleus. Then, when I am talking about S subshell, okay, so when I am talking about S subshell, all of us we know this will be 1s, no doubt, and this will be 2s. So that means 2s will be larger compared to 1s. 2s will be larger compared to 1s. All of you have understood? Okay, all of you have understood? So that's where we have the S subshell, 1s, 2s. If I want to move to 3s, it will be much more larger. Okay, so don't worry. What are these empty regions? We are going to discuss. Okay, but first we are going to talk about boundary surface diagrams. All of you have understood? So in that case, if the question is based on P subshell, if the question is based on P subshell, so this is related to S subshell. Okay, if the question is to draw the boundary surface diagram for P subshell, so those dots, they are not electrons, Rohan. Okay, so that will be the regions which will be having high amount of electrons where we can find. Okay, so that dots are not indicating the electrons, they are nothing but our imagination or our representing the region where probability of finding the electron is very high. Okay, so subshell, so that's what all of you should understand here. One thing, that subshells are nothing but our representation. In reality, these subshells are not there, but it's our imagination. So based on the energy of the electron, based on the region where electrons are found, so based on that we have different shapes and we have given the name. That is also based on the spectral region, peaks which is found in the spectral region. So based on that we have given the name it as SPDF. Okay. Now when I am talking about 1s, so these dots indicates that that's where we have the high region or high probability region where electrons can be identified around the nucleus. Though those dots, they cannot be electrons. They are not electrons. They are the representation. Shading, we will call it as shaded region, right? Same logic is applicable here. Okay? So same logic is applicable for 1s also, 2s also. And if you find here, we have found plane region, nothing is there. So this is the region where probability of finding the electron is almost 0. May not be exactly 0, but almost 0. Therefore, to show that one, we have not shaded this one. Okay? Whether I am clear? So that's where we have 1s, 2s. Now when it comes to P subshell, it is having, first sentence should be, it is having dumbbell shaped structure. It is having dumbbell shaped structure. And all of us we know, P subshell they are having 3 orbitals. P subshells they are having 3 orbitals. So if you go to the magnetic quantum number, it was talking about orientation, right? So it was talking about orientation. That's where for S subshell that may not be considered, but for P subshell we are going to consider. Because all these 3 orbitals, they are in the different orientations. Okay? Now, if Raghavendra sir is standing like this, you people think that I am standing straight. So if I stand like this, then you can see that Raghavendra sir is bending on one side. So on what basis we are telling? Because we are imagining that there is a vertical axis. In reality it is not that. We are imagining there is a vertical axis. Anything, if I am getting deviated, then we can tell that Raghavendra sir is bending on one side. So same thing is applicable here. We can have the axis. Okay? So that's where I have the 3 axes. So one is y, and one is x, and one is z. So that's where I have the axis px, py, and pz. Okay, px, py, pz. Please remember, p should be small letter and x, y, z should be subscript. So that's where we have the px, py, pz. So this is the only thing we have to select the axis. It's up to you. Rohan, yes, absolutely correct. Yes. Okay. So that's where we have the axis. You can take this one as px, this one as py, this one as pz, or you can interchange the axis but maintain the constant form. For all the 3 orbitals, you have to maintain the constant axis. Don't change one from one orbital to another orbital. You should not change. Keep it constant. But it's not compulsory that I have to represent this one as y only. I have to represent this one as x only and this one as z only. It's Raghavendra sir's wish. If I ask Rohan, then he can tell that, sir, I'll consider this one as x. So this one as y and this one as z. Now my wish. Yes, you can do. But only thing is, for rest of the shapes also you have to maintain the same axis title. Okay? All of you have understood? Now, we have one of the p orbital which is called as px. Or, to be more appropriate, I will use the word as 2px. Because from energy level 2, p subshell will start, right? So 2px. So in that case, the shape of the orbital will be along the x-axis. It will be along the x-axis. That's where I have the px orbital structure. That's where I have the px orbital structure. Fine. Same way, we have another orbital. Now observe it carefully. Since py have taken this one, I will maintain the same. And since px I have taken this horizontal line, I will maintain the same. And pz I will maintain the same. I am not going to change. I will maintain uniformity. Okay. Now next one will be 2py. Next one will be 2py. That means it should be along the y-axis. It should be along the y-axis. That's what I mean to tell. This will be along the y-axis. All of you have understood? Okay? Now, last one, because p subshell will be having 3 orbitals. Observe it once again. So, py, py. So, here also, I have taken px. So, here also px. So, this one, I will make it as pz. Okay? So, 3 axes I have taken. And the next one will be 2pz. Next one will be 2pz. So therefore, it should be along the z axis. It should be along the z axis. Okay? So that's where I have the structure of p subshell. I have taken the example of 2p. That's where I have the structure of p subshell. All of you have understood? So you should be labeling the axis. Without labeling the axis, if you just draw the picture, it will not have any weightage. Okay? Say for example, I have written the structure, but I have not labeled this one. Then it's of waste. Okay? You have to label the axis, and you have to show that 2px will be along the x-axis, and 2py will be along the y-axis, and 2pz will be along the z-axis. You have to label the axis along with the labeling of the orbital. You have to label the axis also. Repeatedly I am telling this one, because some students will not label the axis and they will expect the marks. It depends on the examiner. They will not give the marks. Okay, so that's where we have the p subshell, which will be having dumbbell shape. Okay, so for 1 mark they can ask, write the shape of the p subshell orbital, or write the shape of the p subshell. Then you should tell just one word, dumbbell. No need to draw the pictures. Okay, so if it is asked for to draw the picture, then it will be for 3 marks. It cannot be for 1 mark. Okay, all of you have understood? Fine. So that's why 2px, 2py, 2pz. Now, I will take only 2px. I will take 2px, and now the question will be to draw the picture of 3px. To draw the picture of 3px. So I will consider same axis labeling, only dumbbell shape I am going to draw now. So now that's where I am going to draw 3px. So this is related to this is related to what? This is related to 2px. Now when I am drawing the 3px, okay, so when I am drawing the 3px, it looks like butterfly, right? Butterfly wing. Okay, dotted line. So here also dots. I have to shade it to show that these are the region where we can find the electrons. Okay, so that's where I have the 2px, and that's where I have the 3px. Okay, so that's where I have the 2px, and that's where I have the 3px. All of you have understood? Any doubts? So if they ask about to draw the p subshell structure, only this much is enough. No need to draw this one. I have drawn that one to make another concept to explain. That's all. All of you have understood? Okay, fine. Now before going to the D subshell, before moving to the D subshell, I will take another concept before going to the boundary surface diagram for D subshell. Even that is there for you people, only F subshell is not there. So before going for that, I will take another very important concept. Okay, so this one I will make it as important. So that is nodes. Word is nodes. Okay, so it is boundary surface diagram and this is nodes. Now when I am talking about the nodes, I can tell that these are the regions around the nucleus. These are the regions around the nucleus where probability of finding the electron is almost zero. Probability of finding the electron is almost zero. It is almost opposite to that of the orbital. It is almost opposite to that of the orbital, where orbital means where probability of finding the electron is very high, but it is opposite where probability of finding the electron is almost zero. Okay, where we cannot find the electron very often. So that's where we have the nodes. All of you have understood? Any doubt in this particular statement? Okay. So in that case, when I am talking about the nodes, there are two types. One is called as radial nodes and another one is called as angular nodes. Another one is called as angular nodes. So there are two types. With lines should we draw the 3px, sir? Means 3px. Better. If they mention 3px, then better to make the axis label. Okay? If they ask. So I will label it. Okay? So I will label the axis. Okay? So this is x-axis. So this is x-axis. Even here also, instead of writing p and all, even you can write simply as x, z and y. That is also fine because you are labeling the axis. So you can just mention as x, y, z. Okay? So that's where I have written. I will make it uniform everywhere. So I will remove this p because it is applicable for all, not only for p subshell. So I will make it as x, y, z. Okay? Axis label I will make it as x, y, z instead of writing px, pz and all. Fine? So that's where we have the axis, x-axis. It is along the 3px will be along the x-axis. Fine? All of you have understood? Okay? Now, when I am talking about nodes, so these are the regions where probability of finding the electron is almost zero, and there are two types of nodes, radial nodes and angular nodes. There are two types of nodes, radial nodes and angular nodes. Now, when it comes to 1s subshell, there are no nodal regions. There are no nodal regions when it comes to 1s. Okay? But when it comes to 2s, there is a presence of one node which is called as radial node. There is a presence of one node which is called as radial node. Got my point? Now when I am coming to the 3px, I will make a statement here. Okay, afterwards I will make a statement. When I am coming to 3px, I can see one of the radial nodes here. I can see one of the radial nodes over there. Okay, so this is the one radial node, one of the radial node. Now if I observe it carefully, if I see this region, there is no electrons, directly nucleus is there, no electron density. And now, since it will be like in a particular angle, so therefore I will make it as angular nodes. I will make it as angular nodes. So that's where when it comes to P subshell, it will be having radial nodes also, angular node also. When it comes to P subshell, it will be having radial node also, angular node also. When it comes to P subshell, listen to me carefully. But when it comes to S subshell, it is having only radial nodes. I will make it very clear. So I will remove this because now we know what we mean by nodes and what are the types of nodes. Okay. Now, on the S subshell side, I can write that there will not be any angular nodes. Because it is a spherical shape. There will not be any angular nodes when it comes to S subshell. Whether you come for 2s, 3s, 4s, whatever it is, but there will not be any angular nodes. But when it comes to 1s, no nodes at all, no radial nodes with respect to 1s. Okay, that's what I have written here. Now, when it comes to P subshell, I can tell that, okay, so number of non-shaded tells the number of radial nodes or angular nodes. So non-shaded region, which will be almost circular, to remember I am telling, it is almost circular, they will be considered as radial nodes, and which is present along the nucleus, that will be considered as angular nodes. Got my point? So naturally when it comes to S subshell, there is no question of angular nodes. Okay, it is applicable for P and D subshell, angular nodes. Fine. So when it comes to P subshell, there will be presence of radial and angular nodes. Both will be there. Radial and angular nodes. In that case, can you tell me what is the speciality of the 2p subshell with respect to nodes? What is the speciality of the 2p subshell? Any one of you? What is the speciality of the 2p subshell? Can any one of you tell me? Here 1s does not have any nodal region at all. Same way when it comes to 2p, anything you can observe with respect to 2p? In general, I have written that P subshell there will be presence of radial and angular nodes. Only, oh very good, Danyata. Okay, so very good. Yes, when it comes to 2p, there is no question of radial nodes. So exceptional case here is 2p does not have radial nodes. Very good. Does not have radial nodes. It will be having only angular nodes. But rest of the P subshells, that means I am talking about 3p, 4p, 5p, whatever it is, all of them they will be having both radial node also, angular node also. But 2p does not have radial nodes. All of you have understood? Any doubts? In this? So please remember, once again I am telling, if they ask about boundary surface diagram, just draw the picture with labeling of the axis with respect to P subshell. No need to discuss anything about the nodes and all if they are asking about boundary surface diagram. Okay? All of you have understood? Fine. So in that case, if you have understood this, now we will move to D subshell, boundary surface diagram for D subshell. S and P, it is done. We will move to P subshell. Okay. So now, how many orbitals d subshell will have? Can any one of you tell me? How many orbitals a d subshell will have? Any one of you? How many orbitals a d subshell will have? Hmm? So it is 5. Very good. All of you are absolutely correct. It is 5. So which are those? Those are dxy, dyz, dxz, then dx square minus y square, and then dz square. Okay? So these are the 5 orbitals. But before that, one sentence. So d subshell will have double dumbbell shape. Double dumbbell shape. That is important. It will have double dumbbell shape. Okay. So then you can talk about the orbitals. It will be having double dumbbell shaped structure. Yes. Now, once again, we have to label the axis. So, x, then y, then z. Okay, I will label the axis. X, y, z. Once again, you have to maintain the constant labeling of the axis. Don't change for next one. Okay. Now, dxy. The simple way to remember, because we cannot show the 3D image, right? So dx square minus, x square minus y square, okay? Fine. So in that case, when I am talking about the picture, it is actually a 3D image which will be difficult to draw in a board. So what you can remember here is dxy, whenever it is asked, whatever orbitals will be there, shape, dumbbell shape will be there, it should present between x-axis and y-axis. It should be present between x-axis and y-axis. So that's where, which are those x and y-axis? So this is the one, so present between them. Okay? Then it will be present like this. Okay, fine. So that's where we have the shaded line. That's how you can remember. So xy means it should be present between the x-axis and y-axis. But it looks like it is along the z-axis. Okay? But one part of the z-axis it will be masked. If you imagine this one as a z-axis, it will be present in front. If it is another part of the z-axis, it will be behind. Okay? So that's where we can draw like this. All of you have understood? Now, when it comes to yz, so as I told, we have to maintain the constant labeled axis. Don't change the label of the axis. So that's where I have the z. Okay? Now, yz, naturally it should be present between y and z. It should be present between y and z. This is y and z axis. So therefore, it will be present here. Then it will be present here. Right? So that's where double dumbbell shape. Okay? So d, y, z. It looks like shapes are similar. It looks like all are looks like similar, but axes they are different. Okay? Now when it comes to dxz, when it comes to dxz, so this is x-axis, so this is z-axis. dxz, so x-axis and z-axis they are present here. So I have to show between them, right? Okay, so x and z axis I have shown between them, and another one will come here. So that's where I have the another thing. Okay, so dxz. So this is related to this one, this is related to this one, this is related to this one. Now when I am talking about dx square minus y square, it's simple. It's very simple. So since it is x square minus y square, it should come along the x and y axis. It should come along the x and y axis. That means like this. Don't forget, we have to show along the axis itself. Like this. All of you have understood? So that's where we have the dx square minus y square. Okay? And the last one, dz square. And the last one, dz square. Okay? So now y, z, x. Now since I have taken this one as a z axis, it should be along the z axis and there will be central circle. There will be central circle will be there. Okay? So that's where we have the dz square. That's where we have the dz square. All of you have understood? If I want to take it as a straight line, you can take it. But you should label the z axis as a straight line. Okay? Since I have taken z line like this, therefore I have shown in this way. Now if you observe it carefully, with respect to the shapes, which one looks different? This was for 1 mark question. If you see the structure of the d orbital, which particular orbital looks different with respect to the shape? Yes. So therefore we can tell that among the d subshell, therefore among the d subshell orbitals, dz square is having different shape. So that's where 1 mark question, if they ask, you should just mention dz square. That's all. Okay. So that's why we have the structure of the d subshell orbitals. All of you have understood? Any doubts? Any doubts in this? Okay. So in that case, shall I remove this? All of you have understood? So if it is asked, it will be for 4 marks and all they will ask. If they are asking about the boundary surface diagram for D subshell, all these things you have to draw. It cannot be less than 4 marks. Okay, all of you have understood? So shall I remove this? Okay. So in that case, with respect to dz square, okay, Dhanyata, you have any doubts? Or you want me to rewrite those things which I have removed? Or you were drawing in your notebook? Okay, fine. I will wait for some time. Okay? Anyway, these things it will be there in your textbooks also. Even dz square, if you want to make it as straight, then make z axis label as straight one from the beginning. Okay, done it. I will wait. So from the beginning, you can make, if I want to show dz square in a straight one, then from the beginning show this z axis as vertical one to maintain the uniformity. Okay? So then even that dz square will become a straight one. And you have to remember that when it comes to x square minus y square, it should be on x-axis and y-axis, exactly on those axes, not in between. Okay? Fine. So that's where we have the boundary surface diagram for d orbitals. Okay, and dz square is having a different shape among the d subshell orbitals. Dhanita, shall I remove now? All these things, shall I remove? Okay, done. Good. So in that case, now when it comes to nodal regions, with respect to the D subshell, whether it will be having radial nodes and angular nodes both, any one of you, whether it will have radial nodes and angular nodes both. When it comes to D subshell orbitals, whether it will have radial nodes and angular nodes both. Okay. See, for time being, I will take one of the P subshell. So this is P subshell. Okay. Now I will take any one of the D subshell, a common one, not dz square. Okay. So this is where I have the D subshell. Okay, D shell orbitals and P shell orbitals. Okay. So in that case, we can clearly see that there is only one angular node when it comes to P subshell orbital. But when it comes to D subshell, there are two angular nodes. All of you can see it here clearly. There will be presence of two angular nodes for P subshell. Number of angular nodes will be equal to 1. Whether I take 2p, whether I take 3p, whether I take 4p, whatever it is, angular nodes will be remaining 1. Okay, because if it is 2px, then 3px will be along this axis only. So only one angular nodes. When it comes to D subshell, number of angular nodes will be equal to 2. Number of angular nodes will be equal to 2. Even number of radial nodes will be equals to 2. Here number of radial nodes will also be equal to 1, but there it will be equal to 2. All of you have understood? But radial nodes number may vary. For 3p it will be 1 radial nodes, but for 4p it will become 2 radial nodes. Try to understand. For 2p there are no radial nodes, but for 3p it will be 2 radial nodes. That means what I mean to tell here is, so this is for 3p. If I go much more larger, then it will become 4p. So 2p does not have any radial nodes, but when I am talking about 3p, it will be having 1 radial nodes. When I am talking about 3p, it should be having 2 radial nodes. Right? 1 is here, 1 is here, 1 is here, 1 is here. That means number of radial nodes are getting increased. But angular nodes are constant. That's what you should keep it in your mind. As I increase the n value from 2p to 3p, 3p to 4p, 4p to 5p. So if I see with respect to the radial nodes, then 2p 0, radial nodes will be 0. 3p it will become 1. Then 4p it will become 2. 5p it will become 3. Right? So that's how 1 it is getting increased when it comes to radial nodes. But when it comes to angular nodes, in all these cases it will be 1 only, constant. With respect to the P subshell, it will be 1 only. All of you have understood? Same logic is applicable for D subshell also. Same logic is applicable for D subshell also. All of you have understood? Any doubts? Any doubts in this regard? Whether I am clear? These things will help you out with respect to the competitive exams and all. So try to understand all these things. So that's where we have to understand. The radial nodes can be variable. And don't worry about D subshell, P subshell. Radial nodes can be variable. And same thing is applicable for D subshell also, no doubt. But angular nodes will be constant. Even for D subshell, whether I take 3D, 4D, 5D, whatever it is, angular nodes will be 2 only. But number of radial nodes will be increasing. Okay? So that's where we have the nodes and boundary surface diagrams. That's what with respect to the nodes and boundary surface diagram. Okay? Now, if that is the case, there can be a question. Write the total number of nodes. Okay? Write the total number of nodes shown by 3p subshell. Shown by 3p subshell. Can anyone write the total number of nodes shown by the 3p subshell? Anyone? Can you write it down? Total number of nodes shown by the 3p subshell. Okay, Sanya. Okay, it will be 2 nodes. All of you will agree it will be 2 nodes. Very good answer. That is because just now I have shown this will be 2p. Okay? About this, it will be 3p. That means this will be 3p. That means 1 angular nodes and 1 radial nodes. Total it will be 2. As she told. Very good answer. Same way, can you tell me what is the total number of nodes shown by 5p? What is the total number of nodes shown by 5p? Can anyone? What are the total number of nodes shown by 5p? Yes, Chidhan, it will be 4. Yes, you are absolutely right. See, for example, this is 2p. Okay. So this is 3p. No need to draw the picture every time. To make you understand, I am writing. So this is 3p. Now this is 4p. Okay. So this is 4p. Then the final one is 5p. Okay. And the final one is 5p. So this is 5p. All of you can see. Fine. Now all together they have only 1 angular nodes. So this is one thing. But there is 1 radial node, 2 radial node, 3 radial nodes. So total 3 radial nodes. Total 3 radial nodes. And total 1 angular nodes. Total 1 angular nodes. So therefore total it will be 4 nodes which will be formed. Got my point? All of you have understood? Any doubts in this? So therefore I can give an equation once again. So total number of nodes. Total number of nodes will be equal to n minus 1. Total number of nodes will be equal to n minus 1. Okay? Total number of angular nodes will be equal to L value. Total number of angular nodes will be equals to L value. That is azimuthal quantum number, L value. Now can you tell me what will be the total number of radial nodes? What will be the total number of radial nodes? Please remember, these things you can expect even in your competitive exams. They have asked. So total number of nodes is equal to n minus 1. So total number of angular nodes is equal to small l, that is azimuthal quantum number. So what will be total number of radial nodes in that case? How to find out? So in form we can tell that it cannot be n minus 2. So total number of radial nodes will be equal to, what is total number of nodes? N minus 1. What is angular nodes? N. So n minus 1 minus n. So total number of nodes minus total number of angular nodes. That should give the radial nodes. That should give the radial nodes. This is what we have the equation. This one you should remember. This is what we have the equation, which you can use it for your examination. Short form. All of you have understood? Okay? Any doubts in this? So it will be n minus 1 minus l. Why n minus 1? Because total number of nodes. It is n minus 1. Then why minus l? That is because angular nodes. So total number of nodes minus angular nodes should give the radial nodes, right? So that's why this is the one. Okay? All of you have understood? Please remember these formulas. Okay? Anyway, I will stop here. Tomorrow I think another 15 minutes maximum this topic will be done. That is structure of atom. After that we will continue with the next topic tomorrow itself. Okay? So we are in the last part. Okay? Any doubts in today's class? Related to today's class, any doubts? No doubt? Okay, in that case, I will stop here. Take care and try to practice from your check sheet. Any doubts, let me know. Okay? Thank you. Thank you. Thank you very much. Take care. Bye.